Hello, my name is Sam DiOrio, and this is my presentation on the molecule titanium dioxide, or TiO2. Titanium dioxide is used in products such as paints and coatings, including glazes and enamels, plastics, papers, inks, fibers, foods, pharmaceuticals, and cosmetics. It's most commonly used for white pigmentation of commercially produced items. TiO2 melts at 1,843 degrees Celsius or 3,349 degrees Fahrenheit. Its boiling point is at 2,972 degrees Celsius or 5,382 degrees Fahrenheit. Titanium dioxide has a density of 4.23 grams per centimeters cubed, and its molar mass is 79.866 grams per mole. In the Lewis dot structure for TiO2, there are a total of 4 lone pairs, represented by each pair of black dots, which are electrons, and 4 bond pairs, represented by the black lines. In the structure, the 2 double bonds between titanium and both oxygens fill titanium's valence shell, which is why it has no lone pairs. The VSEPR shape of titanium dioxide is quite simple. It has a linear molecular shape, and therefore has bond angles of a straight 180 degrees. TiO2 is polar, and it is an ionic compound due to its high oxidation levels and due to it containing a metal and a nonmetal. Titanium dioxide is produced from either ilmenite, rutile, or titanium slag. Titanium pigment is extracted by using either sulfuric acid through the sulfate process or chlorine through the chloride route. The sulfate process employs simpler technology than the chloride route and can use lower grade, cheaper ores. However, it generally has higher production costs and with acid treatment is more expensive to build than a chloride plant. The chloride route produces a pure product with a tighter range of particle size, but anastase pigments can only be produced by the sulfate route. The sulfate route is perceived to be less environmentally friendly, but acid recycling combined with other byproduct developments can make it as clean as the chloride route. In the sulfate route, there are 3 main stages. The ore, usually in ilmenite, is dissolved in sulfuric acid to form a mixture of sulfates. Any iron is removed from the solution so the color of the final product is not spoiled. The titanyl sulfate is then hydrolyzed in a solution to give insoluble hydrated titanium dioxide. The final stage involves heating the solid in a calciner to evaporate the water and decompose the sulfuric acid in the solid. It also turns the solid into seed crystals, which can be milled to the size needed. These crystals can be coated with another substance, such as aluminum oxide, to make the titanium dioxide mix more easily with liquids or extend the life of the paint manufactured from them. There are 2 main stages to the chloride process. First, the dry ore is fed into a chlorinator together with coke and chlorine to make titanium chloride. Once the fluid bed has been preheated, the heat of reaction with the chlorine is sufficient to maintain the temperature, and recycled liquid titanium chloride may be used to control the temperature. The next step involves the oxidation of titanium chloride by burning it in oxygen with another combustible gas, such as carbon dioxide. By adding seed crystals, the titanium dioxide is formed as a fine solid in a gas stream and is filtered out of the waste gases. Crystal growth is controlled by adding nucleating agents to the gas stream, and the products are cooled by mixing with chlorine gas. The product is then washed and dried before milling and surface treatment. The surface treatment of the base pigment is very important, and the surface finishing unit can account for up to 1/3 the cost of the titanium dioxide plant. The treatment is needed to maximize optical properties, improve durability and reduce yellowing, and improve dispersibility. In this article, it discusses if titanium dioxide is harmful and why Dunkin' Donuts decided to stop using it as a pigment. The main reasons why TiO2 is so appealing is because it just makes the food look better. It doesn't dissolve in water, it isn't particularly reactive, and it isn't easily absorbed into the body from food. The high refractive index of the compound is similar to that of some very expensive gems and even surpasses some of them. The FDA allows up to 1% food-grade titanium dioxide in food, and it doesn't need to be on the food label. A reason why Dunkin' Donuts has departed from using TiO2 in their food is because it's a nanoparticle. It has recently been noticed that the smaller powders are, the more toxic they get, and TiO2 is a powder. TiO2 would still have to be consumed in vast amounts to have any effect on a consumer, but Dunkin' Donuts seems like they're not going to take any chances. So, is it harmful? The answer is yes, but the intensity of its toxicity is so minute that it's fine to be regularly eating it in the foods that it's in, like donuts, bread, any white pigmented foods. That was my presentation on titanium dioxide. Thanks for listening.